Hey guys, today we're talking about imaginary numbers. Now, that might sound kind of fictitious or made up, but imaginary numbers actually have some real life applications. Now, what exactly are imaginary numbers? Well, imaginary numbers result from taking the square root of a negative number. You guys have learned that you can never take the square root of a negative number because the square root is the inverse operation of squaring. And any time you square something, whether it's positive or negative, the result is positive. So for example, if I take the square root of negative 25, it's really equal to the square root of 25 times the square root of negative 1, and that's going to result in this thing known as 5i. So this is an imaginary number. So let's talk about square roots. Square root of k. When k is positive, so for example the square root of 25, we know that the square root of 25 has two solutions. It is both the square root, positive square root of k, and the opposite of the square root of k. So let's just use that example again. If I take the square root of 25, I have two solutions, both positive 5 and negative 5. Because if I go back the opposite direction and I square them, if I square a positive 5, I'll end up with 25. And if I square a negative 5, I'll end up with 25. Alright, now what happens if I have a negative value for k? In other words, a negative number under that radical symbol, or the square root symbol. This also has two solutions. Now the solutions go like this. I have I times the square root of k, and I have negative I times the square root of k. So let's just take a look at a few examples, and I think it will start to make sense. What is I exactly? I is the square root of negative 1, and therefore I squared is the square root of negative 1 squared, and you've learned that squares and square roots are inverse operations. So they undo each other. In other words, what you're left with when you square the square root of negative 1 is simply negative 1. Okay, let's compare the results of these two equations by solving for x. In example A here, we have x squared is equal to 100. In other words, if I square some value for x, I should get 100. Well, in order to solve that, I'm going to take the square root of both sides. So the square root of x squared is x, and the square root of 100, as we just talked about up here, should have two solutions. It should be both the positive and the negative values of the square root of 100, which we know is 10. So our two solutions here are positive and negative 10. In other words, if I were to square positive 10, I'd get 100. If I were to square negative 10, I would also get 100. Alright, let's compare that to solving this equation. X squared is equal to negative 100. Now in other words, if I square something, I should get a negative 100. But you guys have learned that that's impossible. Anytime you square a number, you'll end up with a positive value, not a negative. So let's solve by taking the square root of both sides. When I do that, I get x is equal to both the positive and the negative, because there's two solutions, I times the square root of 100. Okay, in other words, what we've done here to this square root of negative 100 is we've pulled out this square root of negative 1 and multiplied it by the square root of 100, because the square root of negative 1 times the square root of 100 is the square root of negative 100. We also said, hey, the square root of negative 1 is simply I, and we know the square root of 100 is 10. So my two solutions here are both the positive and the negative values of 10i. Now, here's how we can prove that to you in our next example. You are asked to do this, so follow along. If I take 10i and square it, let's go back here a second. If I take 10i and I square that, remember, I have to square both the 10 and the I. So that's 100i squared. Well, remember, I squared is equal to negative 1, and 100 times negative 1 is equal to negative 100. Likewise, if I put a negative 10i inside that parentheses and square that, I will get a positive 100 times an I squared, which also results in negative 100. All right, so let's take a look at a few more examples here. In example 2, we're asked to solve this one for x squared, or sorry, for x. So in order to do that, we're going to solve it just like a normal equation, and we're going to get x by itself. So we have 5x squared is equal to, and we're going to subtract that negative 405 over. Now I'm going to divide both sides by 5, and when I do that, I get x squared is equal to negative 81. All right, now in order to solve for x, I now need to take the square root of both sides, and when I do that, I see that I'm going to end up with this negative number under the square root. Well, again, this can be broken down into the square root of negative 1 times the square root of 81. And I know the square root of negative 1 is simply I times the root 81. Now the square root of 81 is 9. So I say my two solutions here are both the positive and negative values of I times 9. Or you can also rewrite it the other way. You could say it's plus and minus 9i. All right, in example 3, we also want to solve for x. And we have 3x squared plus 16 equals 4. Again, we're going to isolate the variable x. So we have 3x squared. We're subtracting 16 over, and that's going to give me negative 12. And then divide both sides by 3. So I get x squared is equal to negative 4. Again, now I see that if I'm going to solve for x, I got to take the square root of both sides. So x is equal to the square root of negative 4, which again, I have a negative under a radical. So my two solutions are going to involve I. So it's going to be both the plus and minus I times the square root of 4, which is 2. So both positive 2i and negative 2i are my solutions. All right, now with any, just like any other number, we can perform operations on imaginary numbers as well. So let's start off by multiplying these two imaginary numbers. When I do so, we're going to multiply the 7 and the negative 10. That gives us negative 70. And we have the I times the I, which gives us I squared. Now keep in mind, I squared is equal to negative 1. So anytime I see an I squared, I'm actually going to replace this. This is really negative 70 times negative 1. Well, a negative times a negative is a positive, so 7i times a negative 10i results in a real number, positive 70. All right, in our next example, we're going to take negative 3 and multiply it to the square root of negative 49. Well, the square root of negative 49 is simply 7i, so I'm going to change that square root of negative 49 to 7i, and it now becomes 3 times 7i, which is, negative 3 times 7i, which is negative 21i. All right, our next example, we're going to add the square root of negative 9, which we know the square root of 9 is positive 3, so the square root of negative 9 is 3i. I'm going to add to that the square root of negative 121. Well, 121 square rooted is 11. So this is 11i, and when we add those two together, we get 14i. All right, example D, we're going to take the square root of negative 144. Well, the square root of 144 is 12, so negative 144 is 12i, and we'll divide that by 16. We can reduce both of those because 4 goes into 12 3 times, and it goes into 16 4 times. So that's 3i over 4. Next, we're going to multiply these two. So let's simplify them first. The square root of negative 9 is 3i. And next is 11i. And so when we multiply those, we get 33. And I times I is I squared. And remember, we said I squared is equal to negative 1. So that's negative 1 times 33, which is negative 33. All right, the last few examples here, we have the square root of negative 25, which is 5i. And we're going to subtract from that the square root of negative 100, which is 10i. And that's going to be equal to negative 5i. And finally, we have negative 3 times, the square root of negative 3 times the square root of negative 3. So another way of saying that is that's the square root of negative 3 squared. Well, again, square roots and squaring undo each other. They're inverse operations. We're left with whatever's underneath that radical, which is negative 3. And finally here, we have 5i divided by That's 8i. And now when we have an I on both the numerator and the denominator, they actually cancel each other out. They act just like a variable there. So our final solution there is simply 5/8.